picking up good vibrations. She's giving me the excitations. I'm picking up good vibrations. She's giving me the excitations. Good vibrations. She's giving me
In order to begin this, the first thing we need to realize is the difference between an incident wave and a reflected wave. An incident wave is the original incoming wave that is going to strike the barrier. So this is the one you're looking at before it hits something. The next type of wave is called a reflected wave. This is the wave that bounces off of the boundary or the border that you were watching. So your incident wave comes in, and then it strikes the border or the boundary, and then you have the reflected wave. So incident wave is your original wave. Reflected wave is the one after it bounces off the boundary or the border. Well, while we're talking about a reflected wave, let's look at what reflection is anyways. Reflection is when the motion of a wave reaches the boundary and then it changes. So you've got the wave coming in, you have your incident wave coming in, it strikes some sort of boundary or barrier, and it bounces off, and then you end up with a reflection. Now, because it's physics and we have all sorts of laws, we have a law of reflection. The law of reflection states that the angle of incidence is equal to the angle of reflection. Please keep in mind that this symbol, that means angle. Means angle. So the angle of incident is equal to the angle of reflection. So when the original wave comes in, whatever angle it comes in at, the reflected wave is going to go away with that same angle. If you're coming in with an angle of 30 degrees in your incident wave, that means your reflected wave is also going to have an angle of 30 degrees. Now, reflection has two types of boundaries. We have a free boundary and a fixed boundary. A free boundary is a boundary that's able to move with the wave's motion. So if you loosely tie a rope onto a pole, and you shake the rope back and forth and it can move with it, that is a free boundary. It's able to move. And when you have a free boundary, you end up with a wave that is reflected off of it. So free boundaries are able to move with the wave's motion, and the wave ends up being reflected. The opposite of that is a fixed boundary. So a fixed boundary is a boundary that does not move with the wave's motion, so therefore the wave is reflected and then inverted, which means turned upside down. So the thing to remember would be a fixed boundary does not move with the wave's motion, and the wave is reflected and inverted. Inverted means turned upside down or turned the opposite way. Turned opposite way. All right, along with reflection, we have refraction. Refraction is when a wave bends while passing from one medium to another. This is caused by them changing the velocity of the wave's speed as it goes through the medium. So if it travels faster through one substance and slower through another substance, what it's doing is it's slowing down the wave speed. Since the wave gets slowed down, then where it looks like it is changes. So if you have a glass of water with a straw in it, you know how the straw looks like it's in a different position inside the water than outside the water? That would be refraction. So refraction is when the wave bends as it goes from one medium to another, and it's caused by the change in the wave's velocity. Also, the wave's speed. It's another way you could put that. We also have diffraction. Now, this is similar to refraction because it's something that happens to the wave as it passes through something, but this is when the wave bends as it passes an edge or an opening. So this is like when you see the light coming underneath the door from a different room. So diffraction is the bending of the waves as it passes an edge or an opening. Now, to put all these three things together, here is like a summary for you. So you have reflection over here. Now remember, reflection is when it comes in and then it bounces off. Refraction is when the wave speed changes. So it's going at a different speed through here than it is anywhere else. So it looks like it moves. And then diffraction is when it passes through a slit or an opening, an edge. And so then it ends up like diffracting all the particles, so it looks different right in here.
This magnifying glass is making my eye look big. Now, why is that?
I don't know.
Please consider the following.
Okay.
When light enters something like air, water, glass, or plastic, it slows down a little. And when it slows down, it changes direction. See how one eye is lower than the other? See? Take a look at this. Here are three straight beams of light. When they go into the piece of plastic straight, they come out straight. But if the plastic is tilted, the beams of light get tilted. See, they change direction so they come out this side offset. Now, what would happen if the piece of plastic didn't have straight sides, but had a curved side, like a magnifying glass? Well, the light would change direction, right? Because the surface of the plastic is curved, each beam of light enters the piece of plastic at a slightly different angle, and it changes direction a slightly different amount. Look, over here the beams of light come together at a single point. This is called the focal point. Now, what about the magnifying glass? Well, suppose your eye were over here, and light from the room were bouncing off of your eye and going through the piece of plastic this way. Well, then the small area at this end would be spread out over a large area on this side. Your eye would be magnified. Ha! Thanks for joining me on Consider the Following.
Bill Nye the Science Guy.
At this point, I want you to turn to your shoulder partner and explain the difference between an incident wave and a reflected wave. If you are still unclear on what an incident wave or a reflected wave is, you need to talk to your teacher. If you and your partner cannot figure it out, if you are confused about anything else, you need to talk to your teacher or other students in your class to help you figure it out. Thanks. Have a great day.
I'm picking up